There are three main types of reactions in chemistry, and one of them are redox reactions. Redox reactions involve a transfer of electrons between two species. Redox reactions contain two processes, reduction and oxidation, which are opposites of each other. There are different ways to define the two terms. In terms of specific elements, reduction is the removal of oxygen, while oxidation is the addition of oxygen. We will now show you some examples. In this example, nickel 2 oxide is reduced by carbon to give metallic nickel. Therefore, the removal of oxygen happens. In the second example, metallic magnesium reacts with oxygen, creating magnesium oxide, therefore combining magnesium with oxygen. In terms of electron transfer, reduction involves the gain of electrons, while oxidation involves the loss of electrons. We will show you some examples again. In the first one, magnesium loses 2 electrons and becomes a positive magnesium ion. It is oxidized. In the second example, oxygen gains 2 electrons and becomes a negative ion, hence it is reduced. In terms of oxidation states, reduction describes a process in which the oxidation state decreases, while oxidation describes a process in which the oxidation state increases. Referring back to the first examples, then in the first one, nickel first has an oxidation state of +2, but after the reaction, the oxidation state decreases and becomes 0. In the oxidation example, magnesium first has an oxidation state of 0, but after the reaction, it increases and becomes +2. In every redox reaction, there is either an oxidizing agent or a reducing agent. A reducing agent causes another species to be reduced and is itself oxidized in the process. In the nickel example, carbon is the reducing agent, as it causes nickel to be reduced. An oxidizing agent is the same thing, just the other way around. In the magnesium example, oxygen is the oxidizing agent as magnesium is being oxidized. Oxidation states show how many electrons an atom has gained or given away. That usually depends on the number of valence electrons. Some elements have fixed oxidation states. For example, the oxidation state of oxygen is almost always -2. The oxidation state of hydrogen is almost always +1. 1A and 2A group metals also have fixed oxidation states of either +1 or +2. However, many main group nonmetals and in particular most transition metals have variable oxidation states. While dealing with redox reactions, it is important to remember the difference between oxidation state, oxidation number, and charge. Oxidation state is marked with a plus or minus sign in front of a Roman number, while oxidation number is marked with a plus or minus sign in front of an Arabic number, and charge is marked with a plus or minus sign after an Arabic number. Redox reactions have very important applications as they play a huge role in our everyday life. For example, redox reactions play a role in the spoiling of food. The oxidation part of the reaction causes the spoilage. As a result, manufacturers add preservatives which act as reducing agents. Another example is aging in humans. Oxygen molecules and other oxidizing agents extract electrons from the membranes in human cells, which can cause a gradual breakdown in the body's immune system. Other applications involve hair bleaching, glasses with photochromic lenses, and metabolism. Thank you for watching this video, and we hope you learned something about redox reactions.